Hello, this video is about equilibrium. Specifically, it's equilibrium in two dimensions. And before we begin, a block of M1, mass 1, is suspended by a rope. The rope is held in place by an O-ring and two other ropes as shown. Draw a free body diagram for the O-ring. Go ahead and pause the video and see if you can do that. All right, there you go. There's your free body diagram of the O-ring itself. So we've got the tension of the first string going to the left here. We're going to call this string T1. The second one we'll say is T2 up here in this direction here. And the third one going straight down is T3. Now notice I didn't do anything with the mass down here. I don't have the weight going down. That's because I defined my system as the O-ring itself and not the mass. And that's very important, especially when you're taking AP, is to define which system you're going to use, because you can use different systems to get the same answer, but you'll have to make sure that you define your system and you stick with it, just like you define your coordinate systems. All right, so today what we're going to do is calculate the forces acting on an object in equilibrium at rest. But I'm going to tell you that these also apply for equilibrium at constant velocity. But I want to specifically focus on strings and objects that are in equilibrium on strings. Okay, so let's go back. A block, mass 1, is suspended by a rope. The rope is held in place by an O-ring and two other ropes as shown. And what I want you to do is to determine the tension in the rope 1, we'll call this T1, in terms of G, M1, and theta. Now here's the deal. On the AP exam, remember, you're not going to use a calculator. I mean, you can, but you'd only use it maybe once or twice in the entire exam on one or two problems, which you can basically do in your head anyway. So the idea is on the AP exam, they want you to define variables based on other variables, not on the numbers, not on the plugging and chugging. Because when you define variables, in this case defining T1 in terms of other variables, G, M1, and theta, then from there you can determine relationships, proportional, inversely proportional, and things like that. So it's very valuable for you to do the algebra and then plug in the numbers later, especially if your teacher's asking you to do that. Okay, so here's our free body diagram. We've already done that. So let's go ahead and start off every single problem with dynamics or with forces involved the same way. Okay, the first thing we need to ask, is the system moving? The answer is no, it's at rest. So it is in equilibrium. Now, if it's in equilibrium, then what we have to do is we have to sum all of our forces equaling to 0 because it's in equilibrium. Okay, so now let's go ahead and sum all of our forces in the x direction and the y direction. Let's start with x here. I've got a tension going this way, and here I've got the x component of tension 2 here, and then in the y direction I've got the T3 going straight down, and I've got the y component of T2 going straight up. Okay, so the sum of all forces in the x direction, it's in equilibrium in the x direction, is 0, so we can say it's equal to T2 times cosine theta minus the tension. So I'm defining the right to be positive and the left to be negative. For the y direction, all right, I'm going up and then I'm going down. So going up is the y component of T2 right here minus T3. Okay, well, I've defined my system so far as being the O-ring itself. So I have T1, T2, and T3 going down from there. But the problem asks for us to define T1 in terms of M1 and G. But they're not in my original equations here or here. So we have to change our system to the mass. Now I've changed my system, and now my mass is the object and not the O-ring. Because now I can go ahead and draw a free body diagram of that one. And now I have T3 going up and the weight of that mass going down. So again, I'm going to go ahead and define my system and change it. And now with this new system, I've got a free body diagram, and now I'm going to go ahead and create an equation that relates to that system. And here it is. So the sum of all forces in the y direction, because the mass is at rest, is T3 going up minus the weight of the mass going down. And we can say, well, weight is equal to mass times G, M times G. So I'm going to go ahead and substitute that in for M1 times G. And then from here, we can move the tension over, or the mass over, to, so here it's on this side of the equation. I can move it way over there, and we get T3 is equal to M1 times G. Okay, so this is our original two equations with our O-ring being the system, but I changed the system and in order to do that, I can go ahead and find out that T3 is equal to M1 times G here. And so now I can just substitute that in. There it is. Bam. All right, so we've got, let's see, we've got two equations here, and we've got two unknowns. So I can go ahead and solve for T2 in this one and substitute it in there. And now I've got T1 in terms of theta, mass 1, and G. So let's start with the equation of T2 here times sine of theta minus M1 times G. All right, I'm going to go ahead and solve this equation, or isolate T2 by itself. And continuing to add M1G to this side. I'm going to go ahead and divide both sides by sine of theta. Here it is. And it cancels on this side, ends up on this side. So now I'm going to take this here and substitute it right in there because it's the same thing. All right, when I do that, I have M1G over sine theta times cosine theta minus T1. All right. All right, so move the T1 over, and if you don't recognize this next step, don't worry. Don't stress out, because the AP readers or the AP exam understands that, well, you can reduce it this far, and if you get this far, that's good enough. But basically, if you have a cosine over sine theta, or cosine theta over sine theta, wait a minute, that's tangent. That's 1 over tangent. So now I can go ahead and take this cosine over sine theta and move it to a 1 over tangent theta, and that's how I get this equation here. T1 is equal to M1 G over tangent theta. So M1, G, and theta are the three variables that it asked for in terms of T1. Okay, so you give it a shot here. All right, I've got three ropes here, and I want you to go ahead and pause the video and see if you can calculate the tension in either rope, whether it be 2 or 1, in terms of M1 and G. We've already done T3, so we're not going to worry about that one. All right, and there you go. You should have gotten mg over 2 is equal to T1 and T2. All right, let's go to something a little bit more challenging here. So for this one, it's a little bit more intense in terms of the algebra, so I'm going to go over it with you. We want to calculate T1 in terms of M1, G, phi, and theta. Remember, when we run out of thetas here, we've got one angle for theta. We want to use another symbol to represent our angle. We're going to use phi, P-H-I, phi. There it is. It's like theta's cousin for angles. All right, nothing different so far, because what we've done, we've recognized that it's in equilibrium both in the x direction and the y direction. So both equations are going to be equal to 0. Once you do that, now let's go ahead and identify all the forces acting in the x and all of the forces acting in the y. Starting with x, we've got T2 times cosine phi minus T1 cosine theta. That's T1 cosine, we'll go in here, this is the positive direction, cosine phi minus T1 cosine theta. That's this guy here. Now let's go in the x here. We've got T1 sine of theta. All right, T1 sine of theta is pulling up in this direction. T2 sine of phi, which is here, pulling up. And then M1 times G, which is our weight, pulling it down. Because we've already shown earlier that T3 is equal to M1. All right, the rest is just ugly algebra here. So what I've done is I've got the first equation, f of x. And I've started here. I got rid of this guy. And so now I can go ahead and just, let's see, I'm going to add this to one side over here. And so we find out that they're equal to each other. And I can divide both sides by cosine of phi. And so that's how I get here. All right, so this is just ugly algebra. Once you set up the problem, the rest is just algebra. So if you have more problems with the algebra than the physics, then I would try to find some refresher videos on how to solve for variables. Okay, so now we've got this T2 here is equal to T1 cosine theta over cosine phi. Well, here, this is T2, and here's our T2, so I can substitute all of this ugliness into this one here. All right, So when we do that, now we've got this big ugly monster. Okay, but it's not that bad. Take a look here. I've got a sine phi over cosine phi. Well, earlier we had cosine theta over sine theta, and that was equal to 1 over tangent. Well, check it out. Sine phi over cosine phi is equal to tangent. Okay, so let's do our algebra here. I've got like terms, or I've got like variable or the same variable in two of these terms. So I'm going to go ahead and pull it out here. All right. And then now I've got this ugliness that's left behind. This sine theta is here. This ugly thing here is here. Okay, moving on. Now I'm going to go ahead and add both sides, m1g to both sides. And so now I've got m1g is equal to all of this mess. And here's our sine over cosine. Remember now, there's a difference though between phi and theta. So you got to be very careful and meticulous about your thinking, and don't make that common mistake that assuming they're the same. They look kind of the same, but they're not. Okay, so we've got our sine over cosine. Bam, that's our tangent right there. And so what we've got here, we've got this sine theta plus cosine theta tangent phi. All right, I want to go ahead and move this over to this side to get our T1 isolated. And there you go. Here is the answer. Okay, so again, I want to strongly suggest that when you do these problems in physics for AP, you want to solve for the variable first, then put in the numbers if you have to. Okay, it's very important because when you solve for the variable, now you can see relationships. You can see how if I changed one thing, how is it going to affect the other? Okay, so that's important. All right, that's it. So remember, if you have any questions or need tutoring in physics, go ahead and give me an email at monroe.watson@gmail.com.